So the shear in the x direction, shear in any direction is when you're talking about an inconsistent dilation. So, or you're dilating in one direction, but not in another. That's typically the gist of it. Right? So, yeah, sorry, I just got a message. Yeah, anyway. Apologies, folks. It was just a couple messages came through. They seemed important, but they are in fact not. So anyway, the transformation T on the standard unit vector, or I'm sorry, basis vector in R2, given by these two columns, and so the matrix transformation gives you 1, 0, C1, but what that's really telling us is the same thing as T of x comma y is equal to x plus cy comma y. So this one I think is a little bit better to show in action than it is to try to explain what's actually happening, because the concept is it's a little weird, but it's when you see it, it makes perfect sense. All right, so let's get 2, 3. Let me actually get the right kind of marker going here. 2, 3. And I'm going to write it again as a column vector. So we're taking that under the transformation where our vector is going to get the y value doubled and added to the x value. All right. So let's take a look and see what happens there. T of xy, again, is equal to x plus 2y comma y. Now we can do this manually. I'll show you manually first, I guess. So 2 plus 2 times 3 comma 3. I don't know why I went square brackets on this. It's weird. It's been a long semester. All right, so 8 comma 3 would be our new ordered pair, which would correspond to the column vector of 8, 3, right? So what that's doing, so 3, 4, 5, 6, 7, of course I didn't give myself enough room, 8, but I think you get the idea, hopefully, that it's elongating it in the x direction, but not in the y direction. So we get a new point here corresponding with our new vector, which would be 8, 3. All right, so it's a stretch in one direction as opposed to the other. Now, in terms of the vector multiplication approach, so you're taking, again, this idea here and using the information that they gave us, make that transformation. All right, so if you look at it, you can see here that this is based off of column vectors, again, of 1, 0, C1, right? So that's some sort of X movement from your original standard matrix or identity matrix. I lost it there for a second. So anyway, what you're dealing with here is something that went from a value of 2 to a value of 6. So you just kind of keep that in mind. All right. But what we can also do is kind of verify that this actually works by the process. So if we take 1, 0, C1 and multiply it by some matrix XY, we're dotting the 1C against the XY. So 1 times X is X, C times Y is CY. Add them together. All right. Then we are dotting the 0, 1 also against the XY. So 0 times X is 0, 1 times Y is Y. So that's the other component. All right. So that gives us what we're looking for, the ordered pair. All right. So what we want to do is just kind of work backwards from that and say, okay, well, what would that C value have to be in order for this to play out the way it ought to? Well, if you really just kind of look at the operation and compare it to the transformation matrix, you see that whatever the C entry is becomes the coefficient of the Y, and everything else kind of stays put. Right. So what this would correspond to would be a transformation matrix of 1, 0, 2, 1. And if we multiply that against the matrix, the vector, column vector 2, 3 instead of XY, using the dot product approach, 1, 2 dotted against 2, 3. So 1 times 2 is 2, plus 2 times 3 is 6. That gives you the 8. And then 0 times 2 is 2. Well, I'll just rewrite it. 0, 1 dotted against 2, 3. So 0 times 2 is 0. 1 times 3 is 3. No change there. All right. So we can generalize by taking whatever our transformation rule is and then make it into a transformation matrix and carry out the multiplication, go from there. All right. So that's the idea there. The one-to-one and onto stuff is useful, but it's more useful in a linear algebra sense. I mean, it does have a place here, but we kind of addressed it with the test value approach on the previous, like the, half lesson, whatever, what we were doing earlier. So it's really not necessary. So I'm just going to toss this because honestly, it really shouldn't have been here to begin with. It does have value. It's worth looking into. It's just really not now, So, maybe I'll come back to it. I don't know, but I don't think it's necessary at this point. All right, so let me stop that recording.